Welcome to our YouTube channel, The World of Piping and Pipeline Engineering. We're here with another exciting piping tutorial, so be sure to watch this video until the end. If you haven't subscribed to our channel yet, make sure to subscribe now. Types of blind flanges and their applications. Blind flanges are essential components in piping systems used to block off a section of a pipeline or a vessel opening. They are solid discs used to cover or close the end of a pipe, valve, fitting, or equipment nozzle. Here's a detailed overview of the various types of blind flanges. Number 1. Blind flange. Blind flanges are essentially boltable blank discs that use for terminating or isolating piping systems. In non-destructive testing such as hydrostatic testing, this type of flange is widely used. By utilizing blind flanges, the possibility of expanding the piping system and installing new equipment in the future exists. Therefore, in the field of piping design, it is also referred to as a future connection. Blind flange lockouts are used during maintenance on piping. It ensures the blind will not unintentionally be removed until all work is complete and all personal safety locks are removed. The most common types of blind flanges are as follows, categorized by their method of connection. Raised face blind flanges, flat face blind flanges, ring type joint or RTJ blind flanges, male and female blind flanges. Each type of blind flange offers unique advantages and is selected based on factors such as pressure, temperature, pipe size, and requirements for ease of installation or disassembly. Proper selection and installation of blind flanges are crucial to ensuring the integrity and safety of the piping system. Number 2. Spectacle blind flange. A spectacle blind flange consists of two metal discs attached to each other by a central section that acts as a hinge. One of the discs is solid, similar to a standard blind flange, while the other has an opening. By rotating the spectacle blind flange, the solid disc can be aligned with the opening to allow flow through the pipe, or it can be positioned to block flow completely. This type of flange is often used for maintenance or shutdown purposes, allowing easy isolation of sections of piping systems. Number 3. Line blind flange. A line blind flange, also known as a paddle blind flange or a blank and spacer assembly, consists of two separate components: a solid blind flange and a spacer. The spade and spacer are placed between two flanges and can be easily removed to open the pipeline or inserted to close it off. Line blind flanges are commonly used in applications where frequent maintenance, cleaning, or inspection of pipelines is required. The difference between blank and spacer in the incorporated bore is that spacer has it, while blank does not. ASME B16.5. This standard covers pressure temperature ratings, materials, dimensions, tolerances, marking, and testing for operational line blanks, in sizes NPS half through NPS 24 for installation between ASME B16.5 flanges in the 150, 300, 600, 900, 1500, and 2500 pressure classes. Choosing the wrong one can lead to leaks, system failures, or even hazardous situations. ASME B16.5 is the standard that governs pipe flanges and flange fittings for sizes half an inch to 24 inches in pressure classes 150 to 2500. However, an important point to consider is that before selecting the flange size, its material must be determined. This information is documented in a specification known as Piping Material Specification, PMS. In ASME B16.5, the material specifications are covered in Section 5 of the standard. To select the appropriate flange material based on the Piping Material Specification, PMS, we refer to Table 1.121 and Table 1.122, which list the suitable material grades for flange selection. For example, One of the most commonly used materials is A105 for forging and A216GR, WCB for casting, which are listed in Table 1.121, Row 1.1 of ASME B16.5. In the same table, there is a column titled Pressure Temperature Rating Table, which refers us to a table found in later pages of the standard. This reference table determines the flange class based on the working pressure and temperature of the system. For the material selected in this example, the reference is given to Table 2.1.1 in ASME B16.5. In Table 2.1.1, the working pressure of flanges is specified for a temperature range of -29 degrees Celsius to 538 degrees Celsius across different pressure classes, including 150, 300, 400, 600, 900, 1500, and 2500. From the process flow diagram (PFD), we extract the temperature and pressure of the pipeline for which we need to determine the flange pressure class. For example, at a temperature of 300 degrees Celsius and a pressure of 80 bar, class 600 is suitable, as it is rated for 79.6 bar, which is very close to the required pressure. However, an important design consideration is that when the operating pressure falls between two class ratings, it is recommended to select the higher pressure class as a safety margin. For instance, at 400 degrees Celsius, if the operating pressure is 130 bar, it falls between class 900 and class 1500. In this case, the preferred choice would be class 1500 to ensure a safer and more reliable design. Note that this principle applies to all types of flanges.